Hello, my name is Joshua Newton, and today I am presenting my investigation on consumer dietary choice in relation to environmental concern. The initial trail of thought for my dissertation question came from being in lockdown last summer. While trying to focus on the positive effects of lockdown, the reduction of greenhouse gas emissions from less transport and the positive effect this has on climate change came to mind. I knew that this would not last, but here I began thinking about sustainable ways that could. The one that stood out to me was a change in our diets. The reason for this was that, although I may not look like one, I am a huge foodie. I was already aware that the production process for red meat emitted a higher level of greenhouse gases than other foods, but I soon discovered the extent of this. This chart, taken from Our World in Data, shows the greenhouse gas emissions of each food type. The emissions are measured in kilograms of carbon dioxide equivalents per kilogram of food product. We can see that red meat, especially beef, produces more emissions than any other food and by a significant amount. One of the world's most important and widespread issues is climate change. So why do we still include the most environmentally damaging foods in our diet? This is what I wanted to investigate. To do so, I carried out a discrete choice experiment to find out what influences consumers' behaviour for choosing their meals. Existing literature does investigate consumer attitudes towards dietary change, but it tends to focus on only one food. For example, this experiment in 2017 focused solely on climate-neutral milk. There is a need for research into consumer attitudes for whole dietary change because most of us do not eat the same food every day. While there are studies in both the environmental implications that different foods have and the consumer attitude towards these implications, they need to be brought together. I will now talk you through my experimental design. The first attribute of my design was weekly diet. The way I have defined this attribute is by listing the main constituents in the main meal for each day of the week. RM stands for red meat, WM represents white meat or fish, and veg is a vegetarian alternative. For example, in level 2, the weekly diet consists of 1 day having red meat as the main part of the main meal, 4 days of having white meat or fish, and 2 days having a vegetarian alternative. Together, these will of course add up to 7. The second attribute, price, is referring to the price of the weekly shop for these foods and was measured per kilogram of each food type. Values for price were calculated by taking an average of price for products using current prices from 4 supermarkets with a share of above 10%. This attribute needs to be included as it is a key factor for most when food shopping. It is also needed to derive the willingness to pay for values for our variables. The levels vary by 20% either side of 100%. The third attribute, carbon emissions, represents the total emissions for these foods for the week. It is measured by a kilogram of carbon dioxide equivalent per kilogram of food. This considers all greenhouse gas emissions and gives them a weight in proportion to carbon dioxide. Values for carbon emissions were taken from research from Poor and Nemechek in 2018. This also varies by 20% either side of 100. The fourth attribute, nutritional value, was created with a scale of 1 to 4, ranking from worst to best. I felt this was important as a factor for choosing meals because as research into nutrition and fitness advances, it becomes more popular to consider. However, I quickly realised that nutritional value is a very subjective matter. This is because those who consider this when food shopping do not all have the same goal in mind. For some, high calories is desirable, and for others, it is the opposite. For this reason, nutritional value was split into calorie content and fat content on an objective scale. Soon after deciding that these were the main attributes to use, I made more changes. Discussing with peers led me to believe that there was an attribute missing that I must include. This was the time and effort put into preparing the meals. To include this attribute, I removed the nutritional contents entirely, as I did not want to include too many variables, and in turn overfit the model. Nutritional value was therefore kept as a constant for participants in the end. My final fourth attribute then became preparation effort. This scale represents the average combined time and effort put into preparing meals for the week. Effort 1 represents the least amount of effort. This could be putting a ready meal into the microwave. And effort 3 showed the most amount of effort, which could be something like preparing a curry. Feedback from a pilot study caused me to make two other changes. Firstly, a 20% deviation from 100% for price caused price to be a seemingly dominating attribute, so this was then changed to 10% instead. Secondly, defining carbon emissions and the meaning behind the values was too complex for participants to consider when making a choice. Instead, the calculated values were put into categories. Low was for weekly emissions being 0 to 49 kilograms per carbon dioxide equivalent. Medium was for 50 to 99 kilograms, and anything above 100 was considered high. Using these attributes and levels, I used Stata to create 39 choice sets split into 3 blocks. Here is one of the choice sets put into a table alongside the status quo, ready to be put into a survey. The status quo was calculated by using questions asked at the beginning of the survey. Participants were asked to input their usual diet in terms of the main components of their main daily meals throughout the week. They were also asked about their usual preparation efforts, and to determine their usual price range, they were asked whether they mostly shop at a budget supermarket, a premium supermarket, or a high-end shop like a farm shop or a butcher's. At the end of the survey, gender, age, household income, and the number of other people they usually shop for were asked for demographical data. The survey collected 101 responses. These responses were manipulated into panel data that Stata could then read as a choice model. The McFadden conditional logic model was the first model used to estimate the willingness to pay. In this model, price and carbon emissions were both statistically insignificant. When demographical variables were introduced to the model, shown here, the price and carbon emissions were both still statistically insignificant. An issue with this model is the assumption of independence of irrelevant alternatives, also known as IIA. Option 1 and option 2 are correlated in a way to separate the usual diet option. Both option 1 and 2 require the participant to change their dietary habit, unlike the status quo. This means that we may assume that the representative utility for the three options is not equal, but instead split between changing diet, which is option 1 and 2, and not changing diet, which would be the status quo. IIA assumes that all three have the same representative utility. In order to loosen the IIA assumption, a mixed logic model can be attempted. In this model, the parameters are assumed to be random between participants. This allows individual preferences to be considered. An insignificance parameter in the conditional logic model may be insignificant due to the variable giving the opposite effects to different participants. In this model, price is significant while carbon emission stays insignificant. Red meat consumption is now insignificant, and when demographics are introduced, these two remain the only significant variables. As price was divided by 10 for the model, this tells us that an individual is willing to pay £3.50 to lower their preparation effort by 1. They are also willing to pay £12.40 to change a vegetarian main meal to either red meat, white meat, or fish. So far, the economic implications in terms of carbon emissions cannot be deduced. This is due to the statistical insignificance of the variable in the current models. The next step I will take to improve the model will be to introduce an alternative specific constant. The reason this will be used is because of the status quo. The usual diet option is the same for all choice sets and so remains constant for each participant. When the carbon emissions variable becomes significant, we can then be confident in looking at this effect and the effects this has on consumer attitudes towards dietary change. Thank you so much for taking the time to listen to my presentation. It's been a pleasure sharing my work so far.